So today we're going to look at a geometric series. A series is the sum of the terms of a sequence. So a geometric series takes a geometric sequence and adds up the terms. Consider this geometric sequence: 3, 6, 12, 24, 48, 96. Recursively, it is defined with a seed of t equals 3, and then the rule: the next term is 2 times the previous term. Explicitly, when n is the counting numbers, this sequence is defined by the rule t sub n is 3 times 2 raised to the n minus 1 power. But what is the sum of the first 21 terms of this sequence? Well, first we got to figure out what is the 21st term. And we'll use the explicit formula, 3 times 2 raised to the n minus 1 power, and then use a value of 21 for n. Well, that being the case, when n is 21, t sub 21, even though it says 20, is 3 times 2 raised to the 21 minus 1, or 3 times 2 raised to the 20th, which is 3 times, what's that, 1,048,576, which comes out to be 3,145,728. So that is the 21st term. So now for this series, we want 3 plus 6 plus 12 plus 24 plus 48 plus ... plus 3,145,728. Now I'm going to use a little trick to find this answer. Some bright person, not me, figured out this trick. And this trick will be helpful for us to find the sum of any geometric sequence. So to start us off, we're going to let S stand for the sum of the sequence we're interested in. 3 plus 6 plus 12, etc., plus 3,145,728. Then I'm going to take every number in this sequence, in this series, because I'm adding them, every number in this series and multiply it by the common ratio. In this particular case, the common ratio is 2. So I'm going to multiply each of those terms by 2. So that will be 3 times 2, plus 6 times 2, plus 12 times 2, plus 48 times 2, and so on, all the way up to 3,145,728 times 2. Doing this arithmetic, I get 2s equals 6 plus 12 plus 24 plus 48 plus and so on, 6,291,456. So what am I going to do with these two series? What I'm going to do is subtract 2s away from s. So in other words, s equal 3 plus 6 plus 12 and so on, minus 2s, which is equal to negative 6, negative 12, negative 24, negative 20, 48, and so on. Hey, look what happens. In the first series, I have a 6. In the second series, I have a negative 6. In the first series, I have a 12. In the second series, I have a negative 12. And so on down the line. So I got a bunch of zeros I'm adding there. What's left behind? From the first series, the first term, 3 is there. And from the second series, negative 6,291,456 is there. So s minus 2s is equal to negative 6,291,453. Then looking at the left-hand side of the equal sign, I'm going to factor out an s. I get a 1 minus 2, which is a negative 1. So negative 1s equals negative 6,291,453. And then multiplying both sides by negative 1, I get s is equal to 6,291,453. So let's just take a moment to review this. We started with a geometric series, 3 plus 6 plus 12 plus 24 on up to plus 3 million whatever. I took that series and multiplied it by the common ratio. Then I took the original series and subtracted from it the same series multiplied by the common ratio. Then I factored out S, the sum of the series, and 1 minus the common ratio, and divided that on both sides, and that gave me the answer. This will work every time.